गुड मॉर्निंग स्टूडेंट्स। ये क्वेश्चंस हैं परमुटेशन एंड कॉम्बिनेशन के एडवांस स्टेज के। अच्छे क्वेश्चन हैं, आप इसको देखिएगा। हम ये क्वेश्चन करेंगे, आपको ये क्वेश्चन पसंद आए तो आप इस तरह के क्वेश्चन के लिए और बोलिएगा। हम ऐसे अलग अलग टॉपिक के ऊपर क्वेश्चन लेकर के आएंगे। ये साइक्लिक अरेंजमेंट के ऊपर क्वेश्चन है, परम्यूटेशन कॉम्बिनेशन का। इसका क्वेश्चन 1 देखते हैं हम। अ बिजनेसमैन होस्ट डिनर टू 21 गेस्ट। देखिए, इस क्वेश्चन को ऐसे करते हैं, टोटल गेस्ट कितने हैं? ये 21 है। ही इज हैविंग 2 राउंड टेबल्स, उसके पास में 2 राउंड टेबल्स है, विच कैन एकोमोडेट 15 एंड 6 persons ईच। ही इज हैविंग 2 राउंड टेबल्स, दिस इज 1 and this is 1. This is table number 1 T1 and this is table number 2 T2. This is for 15 persons, this is for 6 persons. In how many ways can he arrange the guest? Basically question is asking that if 21 persons come and he has only facility of 2 tables on which on the one table 15 persons can sit and on the other 6 persons can accommodate, how will the person accommodate them? So look at that. Here for this table he has to select 15 persons and here he has to select 6 persons. यहाँ पे इसको 15 persons को select करना है for table 1 T1 and for table 2 has to select 6 persons, out of which 15. Whether he will select for table 1 or for table 2, it is his choice. Okay, take case 1. First he selects or host selects 15 persons for table 1 out of 21 persons. This will happen. So he will select 21C15. The remainings are 6. 21 minus 15. And for T2 he will select 6 persons out of 6. This becomes 6C6. This is case 1. Okay, so this is equal to 21 factorial divided by 15 factorial 6 factorial, multiply this into 6 factorial divided by 6 factorial and 0 factorial. This is the resultant till the selection is made only. Still sitting is not made, only selection of people is made. Case 2. First he selects for table 2. In case 1 he selects 15% for table 1. If he selects 6 persons for table 2, he will select 6 persons for table 2 out of 21. So this will be 12C6. Sorry, 21C6. This will be 21C6. Now for table 1, 15 persons are remaining, are left, and he has to select 15 out of 15, 15C15. So total selection made 21C6 into 15C15 equal to 21 factorial divided by 6 factorial, then 21 minus 6, 15 factorial into 15 factorial divide by 15 factorial and 0 factorial. This makes cancel and 0 factorial is 1. 21 factorial divided by 6 factorial and 15 factorial. Here again 6 cancel each other, then 21 factorial divided by 15 factorial, 6 factorial. So these are this same. These two are same. So there is no difference whether he selects for table 1 or table 2 as the first choice. He can select either for the table 1 or for the table 2. It depends upon him, because calculation wise there is no problem whether he select for table 1 or table 2. So there is the selection of the people for either for table 1 first or table 2 next, then either table 1 first or table 2 next, or here table 2 first table 1 next. So this, in this way selection is made in this way: 21 factorial, 6 factorial, 15 factorial. So this is the way. Again, now still there is a person are selected. Now the host has to make them sit on the tables. So this is the cyclic arrangement you see at the T1. If he has to make arrangement of the 15 persons on the round table, he has to fix 1% at the fixed point 1. Then the remaining 2, 3, 4, this way, 7, this way up to 14th, then up to 15th, this way. He has to fix 1% at the round table. To make his position fix, he can change 14% in the different ways. So the total number of ways he can select on the table 1 is 14 factorial. Likewise on the second table, he has to fix 1% position fix, and for another 5 persons, remaining 5 persons will be arranged in 5 factorial way. So total 21 guests can be selected and their sitting arrangements can be made accordingly. If there are 15 person sitting arrangement on the one round table and 6 person sitting arrangement on the 6 round tables, so it will be equal to 12 factorial. Clearly I am writing here 12 factorial, not 12, it is 21. 21 factorial divide by 15 factorial, 6 factorial, and remaining 14 factorial and 5 factorial. अगेन आई एम एक्सप्लेनिंग. आप एक चीज़ देखिए, दो राउंड टेबल हैं, एक पर 15 लोग बैठ सकते हैं, एक पर 6 लोग बैठ सकते हैं, 21 लोग बिठाने हैं. तो या तो आप 15 सेलेक्ट कीजिए, आइदर यू सेलेक्ट 15 फर्स्ट और 6 फर्स्ट. देयर इज़ नो डिफरेंस इन दिस सिलेक्शन प्रोसीजर. आपने यू फर्स्ट इन द फर्स्ट स्टेप यू हैव सेलेक्टेड 15 फॉर द फर्स्ट table and 6 for the another table. Then you have to make sitting arrangement by fixing one place fix for one candidate, and 14 can be arranged into the 14 factorial ways. On the second round table, one person has to be fixed on one fixed place and remaining 5 has to be arranged as per the 5 factorial ways. So this happens this. These are the advanced permutation combination questions where you have to think like this. If you want to, you can pause the video or note down it. Now come to the next question. A tea party is arranged for 20 persons. Total persons how much? 20. Total persons 20. Along two sides of a long table. Here a long table two sides. This is side 1, this is side 1, and this is side 2. This is side 2. With 10 chairs on each side, there is 10 chairs. 1, 2, 3, up to 10. There are 10 chairs this way. And there are also 10 chairs. 5 persons wish to sit on one particular side. Suppose 5 persons want to sit here and 2 on the another side. Suppose 2 wants to here sit here is this side. In how many ways they can be seated? Already 5 has selected their ways for the one side and 2 have selected their ways on the अदर साइड. 2 पर्सन एक जगह बैठेंगे, 5 पर्सन एक जगह बैठेंगे. 20 में से अब रह गए कितने? 13. रिमेनिंग पर्सन्स इक्वल टू 13. क्या करते हैं? इस साइड को टेक दिस साइड. 5 has already fixed their position ki we will sit at this side, and for this side out of 13 5 has to selected 13C5. And for this place we have to select 8 persons because 10 sitting arrangements are there, 10 chairs are there, 2 have already occupied their place, remaining 8 chairs are there, and out of 13 5 have been selected for side 1. Remaining 8 persons, out of 8 we will select 8 persons. Okay, now persons are 10 persons are on the one side and 10 persons are on the side second, but it is not given that all will sit all together or differently, so they can sit anywhere. Side 1 person 10 persons can sit in 10 factorial way, side 2 person can sit in 10 factorial way. This is equal to 1. So this total sitting arrangement can be made by this way. This way. This is the proper solution. Again I am explaining this. This is the table and two-sided table. At the one side 10 persons can sit, on the another side further 10 persons can sit. If 10% sits on the one side and 10% on the another side, the first thing is that they can be arranged in 10 factorial ways, and out of these 10 5 have selected their position, and on the other side 2 have selected their position that we will sit on this side. Now once 5 have selected their position, the remaining 5 will be selected out of the remaining candidates. Out of 20, 7 have selected their sides, 5 to one side and 7 to the other side. So remaining 13 are free candidates. You can imagine they are free candidates. They have not been selected any position for their, or they have not selected their side to be seated. So out of 13, whether you select for side 2, that is 13C8, for side 2 8%, and remaining are 5 for the side 1. On the both side there are 10 candidates, so the 10 persons will sit in 10 factorial way and the 10 factorial way. This and this is same. This and this is same because we know NCR equal to NCN minus R. We know this. So this is same. So these questions are cyclic arrangement questions. There is the proper method and algorithm to solve these questions. One more thing, there is small basic difference between question number 1 and question number 2. This question, what is this? There is one table where the person's sitting arrangement has to be made. Here it is two table. Try to understand. This is two table, not sides are given. When the sides is not given around the table, we have to make the sitting arrangement. We have to make a particular person sitting fix. We will fix his seat. Then the remaining persons will rotate anywhere. But this is the basic difference between these two questions, question number 1 and question number 2. When we have to make the sitting arrangement of the persons over the round table, not to the sides, we have to make the seats for one person fixed, and the remaining person minus 1 will be factorized as the n minus 1 factorial. In the both situation, in the T1 and T2 we did this. In T1 we had 15 persons, we make fixed one person seat, remaining 14 persons were seated in 14 factorial way. And in the table 2, out of 6 we make one seat fixed, and the 5 persons will make arrangement in the 5 factorial way. But in the question number second, this is not required here. Try to understand and keep in mind always. Now we are going to the question third. Question third, there are 10 lamps in a hall. Each one of them can be switched on independently. This is very important line. No two lamps can be switched on simultaneously. If we want to on any lamp, we have to press one different switch. Find the number of ways in which the halls can be illuminated. This is the question. How we can make light in the hall? So here you think every lamp has two options. Has two options. On, off. One number of ways hall can be illuminated minus number of ways hall cannot be illuminated. Why? Why this? Because every lamp has two options. It can be switched on or it can be switched off. So when you make any lamp on or you make it off, if you make every lamp off, the hall is dark. At least one switch must be on to make light available in the hall. So hall can be illuminated by switching on at least one lamp. At least one lamp. So switching on at least one lamp for 10 lamps having two options for each lamp is 2 option raised to number of objects taken together. This is 2 raised to 10. This is value of this, value of this. 2 raised to 10 minus number of ways holes can be eliminated. So there is only one way. Only one way. Hole holes all switches are off. This is only one way. So the number of ways holes can be eliminated is so the number of ways hole can be illuminated is this is only one. So this minus this 2 raised to 10 minus 1. This is 1024 minus 1. This is 1023. Explaining again, please give attention. In a hall there are 10 lamps. Then it is full stop. If there is lamp, there must be two options, putting on or off. It is with this option. It is very common sense understanding that when there is a lamp, there are two options, either on, you make it on, or you make it off. Each one of them can be switched on independently. No two lamps are joined together either from any switch. No, not two lamps are giving light. Find the number of ways in which the hole can be eliminated. So we noticed that every lamp has two options, on off, and every lamp is operated independently. So the number of ways in which the hole can be eliminated is number of ways hole can be eliminated minus number of ways hole cannot be eliminated. It is must to be noticed, because every hole can be eliminated either by one lamp, two lamps, three lamps, or switching all the 10 lamps. So at least one lamp should be on is required. At least one lamp. That's the case when hole can be eliminated. So to make at least one lamp to be on, the way is 2 raised to 10 when all objects are taken together. 2 raised to 10, and there is only one way that hole cannot be illuminated, then that you make all the switches off. So 2 raised to 10 minus 1, 2 raised to 10 is 1024 minus 1 1023. Now come to the question number 4. In how many ways 3 mathematics books, 4 history books, 3 chemistry books, and 2 biology books can be arranged on a shelf so that all books of the same subjects are together? So this way. This is 3 mathematics books, 4 history books, this is 4 history books, 3 chemistry books, 3 chemistry books, 2 biology books. These 2 biology books. We have to arrange in an shelf that same subjects are together. So this is one unit. This is one unit. This is second unit. This is third unit. This is fourth unit. You can make this here 2b, or you can make this here 3m. So these four units can be arranged in 4 factorial ways. Understand? So these four different units can be arranged in 4 factorial ways. You can interchange their places. You can make 4 history books in between biology and mathematics books. You can make biology books between history and chemistry books. Here in question it is written, not a sequence, fixed sequence is given. You can arrange in different manners. So you can arrange by considering every subject book as a single unit in 4 factorial ways. Then come to arrange 3 mathematics books in 3 factorial way. Suppose this is M1 book, M2 book, M3 book. You can arrange M2, M3, M1, or M1, M3, M2, or any other way, 6 ways. And 4 history books into 4 factorial ways, 3 chemistry books into 3 factorial ways, and 2 biology books itself into 2 factorial ways. So this is the number of ways you can make arrange them. You understand it? Again I am explaining. We have to arrange 3 mathematics books, 4 history books, 3 chemistry books, and 2 biology books in a shelf. So we tried to understand in this way what we have drawn here. This is 3 mathematics book, this is 4 history, this is 3 chemistry, this is 2 biology. And we have to arrange that same subject books are all together. So, but before that we can place all the subject books in the different patterns. Here as the question we wrote in the first sequence mathematics, then history, then chemistry, then biology. But during arrangement we can put biology in the first, or history in the first, or chemistry in the first, or at the second either mathematics or history or chemistry, in the third another two, at the last remaining one. So these books considering all subject books as the single units. So there are 4 units because these books are of 4 subjects, so they can be arranged in 4 factorial ways. 4 subject books can be arranged in 4 factorial ways. After arrangement, 3 mathematics books can be arranged in 3 factorial ways. 4 history books can be arranged in 4 factorial ways. 3 chemistry books can be arranged in 3 factorial ways. And 2 biology books can be arranged in 2 factorial ways. So this is the solution of this type of question. Regularly we are coming with the different problems on different topics as the students ask us. Already we have shown the very good questions on the ratio and proportion, on percentage, on time and distance, on indices and sorts, on HCF and LCM, on binomial theorem, on arithmetic progression. You can see that video. This is third. This is seven. That's second. This is first. You can pause the video if you are noting down. Thank you for watching.